Welcome back. We have already discussed what is generative adversarial networks in our previous video. That is, the generator creates new data, while the discriminator evaluates whether the generated data is real or fake. Now we will understand it with an example. Imagine we're in a world where two characters are competing. One is the generator and the other is the discriminator. Let's first talk about the generator. The generator's job is to create fake money. However, this isn't just any random money. It needs to look as close to real money as possible. So, it uses the data it's learned about real money to create fake versions that can trick someone into thinking they are real. On the other hand, we have the discriminator just like a detective. It's given both real money and fake money, and its job is to figure out which is which. It looks at things like the size, color, texture, and other details of the money to determine if it's real or fake. Now, here's where the magic happens. Both the generator and the discriminator are in a competition. The generator tries to create better and better fake money to fool the discriminator. The discriminator, meanwhile, gets better at detecting the fake money. This entire process of competition between the generator and the discriminator is how a generative adversarial network, GAN, works. The generator creates, and the discriminator critiques, pushing each other to get better and better at their tasks. Let's consider how a variational autoencoder works in the context of face recognition. Imagine you have a large dataset of face images, each showing different people with varying expressions, lighting conditions, and angles. The VAE can help to identify patterns and features in these images that are most important for recognizing faces. The encoder part of the VAE takes each face image and compresses it into a smaller, simpler latent representation. This process captures the most important features of the face, such as the position of the eyes, nose, mouth, and overall shape of the face, while discarding less important details like background noise or minor facial expressions. This latent space represents the compressed information in a more abstract form, such as numbers or vectors. Think of it as a summary of the face that can be used for recognition, but in a smaller, more manageable form. The decoder part of the VAE can reconstruct the image from the latent representation. Essentially, it tries to rebuild the face image, but without any unnecessary noise. Now, when a new face image is provided, the VAE first compresses it into the latent space. The model can compare this latent representation with previously stored representations of known faces. If the new face is similar to one of the stored latent representations, the model can recognize it as a match. This concludes our first module. We will begin with the second module in our next session. Thank you.